Okay, so in this video I'm going to talk about what we call the parallelogram property for vector addition. So the way that I'd shown you in the previous video how to add was to take two vectors like that and place them head to tail, and then you get the sum there. So if this was vector A and this was vector B, then this would be vector A plus B. Okay, we call that the triangle property. So basically what it means is you set it up into a triangle, and then the, uh, the, the sum is the third side of the triangle. So that's the triangle property. The triangle property is how you want to view the vector addition if you have the vectors placed head to tail, right? So like the tail of one is at the head of the other. The parallelogram property the way you often think about it if the two vectors are drawn tail to tail. So I'm just going to write this down here. Okay, so the the way the parallelogram property works, if you have two vectors A and B which are drawn tail to tail, so A is here and B, so they have the same tail, is here, then what you're going to do to get A plus B is complete the parallelogram. So what that means is you take these two vectors as sides in the parallelogram and then draw the opposite sides of the parallelogram. So in this case, this side of the parallelogram would be another vector which would be equal to vector B because it's the same magnitude, same direction. And this side of the parallelogram would be a vector equal to vector A. So now I have a parallelogram. Then the sum A plus B, well, now I can see that I have a triangle along the bottom here, or two sides of a triangle, and I can kind of draw the diagonal here. And there I've got the triangle property here, or up top I've got a triangle up here too. So this diagonal is the vector A plus B. Okay. Okay, so in this parallelogram, the diagonal of the parallelogram will be the vector A plus B. Okay. Um, nice thing that this one actually shows you is that you could think of this as A plus B gives you vector A plus B, or you could think of it as B plus A. So you can see that A plus B is equal to B plus A, which, you know, for addition that makes sense. When we add numbers, that should be the case, but vector addition is not the same as adding two numbers. So it's maybe not a given that this property was true, that it doesn't matter the order that you add two things, but that diagram should show you that it doesn't matter. Okay, so here we're going to look at an example where we're doing vector addition. So you have vectors A and B, and we know the magnitude of A is 2, the magnitude of B is 3. The angle between A and B is 30 degrees. We want the magnitude of A plus B. So these two symbols mean magnitude. One thing you have to, well, drawing would usually help. So we want to draw this situation. But one thing that just needs some clarification is when we say the angle between them is 30 degrees, what does that mean? Because there's a lot of different ways I could draw A and B. And where would the 30 degrees go? It is assumed when you say that that means if we drew A and B, so if drawn tail to tail. Okay, so that means I'm going to draw vectors A, which will have magnitude of 2, and B, which will be a little longer, with a magnitude of 3. So that's vector A, and that's vector B, and this angle between them when drawn tail to tail is 30 degrees. So I want the sum of the magnitude, so the magnitude of the sum. So because they're drawn tail to tail, the way I'm going to do this is I'm going to complete that parallelogram. So I'm going to draw a side parallel to vector B, which will be a vector equal to vector B. Right, so this is vector B as well, and this is vector A as well. So remember this side, the magnitude of this side is 2, and the magnitude of this side is 3. Okay, so now the diagonal, I'll draw the diagonal. Diagonal is this side right here, or this vector right here. So this is A plus B. So what I want to do is I want to figure out the magnitude of this diagonal. The way we're going to figure out the magnitude of this diagonal is we're going to look at this triangle right here made by A, B, and A plus B. So notice I know two sides in the triangle. I know this side has length 2 and this side has length 3. So if you remember back to your grade 10 trigonometry, if you have two sides, you can get the third side as long as you have one angle. So we just need one of the angles in this triangle. And we don't have it yet, but let's say I'll call this angle here theta. I can figure out theta because I know this side, this angle here is 30 degrees. And because these two sides are parallel, the rule from grade 9 was that the sum of these two angles, theta plus 30 degrees, is equal to 180. You might have called that your C pattern, where you had two parallel lines. So theta is equal to 180 minus 30. So theta equals 150 degrees. So this is 150 degrees right here. So now I have two sides and an angle, and I need the opposite side. So if you will get a grade 10 trigonometry, this should be obvious what you're going to do. You're going to use your cosine law. So the cosine law said a squared, sorry, it said c squared equals a squared plus b squared minus 2ab cos theta. In this case, c would be the magnitude of vector a plus b squared. A would be the magnitude of a. Make sure that you're including these magnitude symbols. You can't just say vector a squared because it doesn't make sense to square a vector. You can square a magnitude, you cannot square the vector. So that's why these magnitude symbols are important in this equation. And you're just going to fill in your missing values here. So magnitude a, that was 2. So 2 squared plus 3 squared minus 2 times 2 times 3 times the cosine of 150. Okay, and then you can simplify that. But the magnitude of a plus b, now this is squared, so in order to get the answer, I'm going to have to do the square root of, here I'll just simplify a little bit. 2 squared was 4, 3 squared was 9, so that's 13 minus 2 times 2 times 3 is 12. I have the cosine of 150. And now this is going to be a decimal. So my suggestion here would be put these numbers into your calculator and get the decimal approximation. So 4.83. Okay, so that's the magnitude of this side. So this side here was 4.83 units. We weren't given, centimeters, meters. We weren't given any units, so we'll just say 4.83 and leave it unitless, just like was done in the question.